Hello, my name is Robert Pierce, but you can call me Bob. I am an undergrad going for my BA in Public Administration in Healthcare at the University of Hawaii, West Oahu. It's my last semester. I didn't already say that. Really appreciate you sharing your valuable time with me tonight. As a fellow night student, I know how valuable your time is. And you got outside responsibilities, you got outside school responsibilities. So time is valuable, and I sincerely appreciate it. My speech tonight is about the Hadron Collider. Anybody ever heard of it before? Okay. Well, to begin with, it's the world's largest machine. And it's also the world's largest particle accelerator. Anybody know what a particle accelerator is? Okay, you're going to find out. When it was proposed to be built, it created quite a stir. Predictions were included that it was going to create a nuclear explosion. It was going to create a black hole. It was going to suck in everything, including us and the Earth, and end life as we know it. Scientists and physicists didn't agree, so they built it anyway. As they will be inclined to do, they just go ahead and do their science things. The Large Hadron Collider is located in Europe. It straddles the French and Switzerland border. It's a 27-kilometer ring over 17 miles of superconducting magnets and accelerator boosters for energy particles. Energy particles are shot in beams around this ring that collide together at the end. Okay? Here's a high-up view of the French-Switzerland border with an overlay of where that ring is. Here's a diagram of the ring. These various stations here are where they conduct different types of experiments. There's one that's called the God particle. Then there's the moments after the Big Bang. Then there's the search for dark matter. And those are kind of clues of what I'm going to be telling you next about what the accelerator does. Like I said before, inside, this is the accelerator here. This is the tube that it goes through, and this is in comparison to human beings or the workers standing next to it. They shoot particle beams in opposite directions at almost the speed of light. And with magnets guiding them, and right before they collide, they have special magnets that squeeze them so that they will pinpoint collide together at almost the speed of light. It's like firing two needles 6 miles apart and having them hit point to point. Why would we want to do this? Because we can? No, we can't, but it's not the only reason. Scientists and physicists believe that conducting experiments like this will help us understand how the universe was created. What they're basically trying to do is create a small Big Bang and then identify what happens afterwards. All those billions of years ago, we had this Big Bang, that's what the hypothesis is, and the universe was created. Well, they ran some experiments for a while, but in 2013, they decided that they were going to shut it down for 2 years and upgrade it. More power, faster, had to have it better. They didn't like the results they got before, so they wanted to be able to have better results and produce an even bigger simulation of the Big Bang. What physicists hoped the upgrades would create was particles that never existed before, and potentially simulate the conditions that were seen in the early universe. And it appears that they did, because the latest accomplishments of the collider was that they smashed together lead ions at over 1,000 trillion electron volts, more than twice than any other experiment of its kind before. By increasing the energy of the lead ion particles, they increased the volume and temperature and created a soupy matter of quark and gluon plasma. This is what was created 1/1,000,000th of a second after the Big Bang. I don't know how they measured 1/1,000,000th of a second, or how they even got to check out what that soupy matter was, but they did in some way. Okay, short speech, short review. The Large Hadron Collider straddles the French-Switzerland border as a 17-mile ring operating as a particle accelerator, and it is the largest machine ever built. 2 super high energy beams travel in opposite directions and collide to try and simulate the Big Bang and create matter that they can study to see what it was like in the universe at that time and as things expanded out. The Hadron Collider was upgraded over a 2-year period just so that they could get more power and see what they could simulate the Big Bang even better. And they did, because they had that lead ion experiment with the 1,000 trillion electron volt increase, and they came up with that soupy matter, that 1/1,000,000th of a second after the Big Bang was what the universe was. So, and we were in there someplace too. So, again with the why. Why is this like so important? Or is this just a bunch of rich scientist guys playing with a really huge machine doing things that they think are cool? Well, yes, but also, in my opinion, scientific discoveries like this help us understand how life works. The creation of the universe is also the creation of us. And understanding science can lead to a better ability to benefit life, benefit medicine, and benefit science in general. The discoveries that are made and the results that people study can never directly understand what they're going to produce in the future. And the more that we discover, the more that we understand, the better things we can produce in our lives, and hopefully make life better. Thank you very much.
Thank you.
Any questions?
Awesome.
Okay.
That was good.
And just push the big button to stop it.